Sean to, just get him over. Dr. Ajay Bissessur, he's a lecturer in University of Kwa-Zulu, Natal, Durban, South Africa. He was the chairman of the scientific committee of the International Junior Science Olympiad, hosted by South Africa in 2011. He's the examiner and member of the National Science Olympiad Committee of South Africa. He's the head mentor of South African team participating at the International Chemistry Olympiads and International Junior Science Olympiads. He is also the member of South African Agency for Science and Technology Advancement, Science, Engineering, Mathematics and Innovation Committee from Department of Science and Technology. Dr. Ajay also happens to be the outreach coordinator for School of Chemistry and Physics at his university in Durban. Now I hand it over to Dr. Ajay to take this further. Thank you, sir.
Thank you. I'm just going to try and share my screen. Coach Tube, it says that the host disabled participant screen sharing.
So yes. Now you can share it.
Okay. There
I've given you the right.
Thank you. There we go.
Beautiful.
Thank you. Let me just get this show on the road and then there we go. I'm trying to work out the time difference between South Africa and I think, well, I've got it right now. It's 3 hours. So, Dr. Brijesh, thank you for inviting me.
Welcome.
And I would like to thank the organizing committee for their invite and for this wonderful opportunity in hosting such an event. It's actually very, very informative and I've actually learned a lot. So you'll see I've got a nice title slide, and my topic for today is bridging the gap between school curriculum-based questions and obviously Olympiad questions. I put a nice picture here where you see bridging the gap, and you'll notice that no matter how bad the bridge is, and the bridge itself got gaps, but it links two different parts of places that will probably have some value in each other. So my first slide was intended to show you that that information about bridging places and bridging gaps and bridging thoughts, etc., etc. Where in the world, in Durban and South Africa I am, so I thought it's nice to give pictures of where you are, and so you know where I come from. And if you see the world map, I think most of you know South Africa. We obviously can't beat India in cricket, but we have a very good rugby playing nation in South Africa. And here we are, and I'm here in a little, on the eastern seaboard, a place called Durban. Durban's got one of the most, it's one of the warmest cities in the world. And we have basically the largest number of, sorry, I'm just getting some feedback. We have the largest number of Indians outside India. And as you know, we settled here quite a long time ago. So here's another very nice picture of our Durban beachfront. You'll notice the stadium where we hosted the 2010 World Cup soccer. Interesting, you'll see there's a long white building at the top. It's called the Maharani, and it was built, Dr. Brijesh, I think when we drove sometimes past there and we saw the Maharani, it has quite a nice name to it. So you see Indians have actually, I live somewhere just on the hilltop behind Moses Mabhida. I'm about 2 kilometers away, so I can walk to the stadium. And you'll often find me on a Sunday morning running on the beachfront. We have a wonderful promenade. It's very, very nice. And as I look out, I can actually see Maharani from my window, and the weather is beautiful. This is the institution I come from. It's called the University of Kwa-Zulu, Natal. The indigenous language on the eastern seaboard is what we refer to as isiZulu. It's the indigenous language. And here is our shield. Now, interestingly, if you look here, there's something called the Westville campus. Dr. Brijesh was here at the Westville campus when he did his postdoc many, many years ago. And that's where I met him. 20 years ago. And it was a university for Indians only during the days of apartheid. If you look at the top, we have the Howard College, the Pietermaritzburg campus, the Nelson Mandela School for Medicine, and the Edgewood campus belonged to what was previously known as the University of Natal. And these were for whites only. So if you were Indian, you only went to the Westville campus, which was previously known as the University of Durban, Westville. And you'll see there's a long building, you'll see there's a sort of a rondavel, and just behind that is where the chemistry building is. And that's where Dr. Brijesh had his little office, and that's where we used to have our little chats. I hope you're enjoying the pictures. Lots have been said about MCQs. I've got 45 slides, so people are going to get very, very worried. Don't get worried. I'm going to flip through very, very quickly because most of the information has been said. I've learned quite a lot. No matter how experienced you are, but you learn every day. And I think I've set so many hundreds and hundreds of multiple choice questions, but listening to all the previous speakers, and I must really thank them because they've also empowered me in terms of the talks that I've given. What catches me with when I spoke to Dr. Brijesh the other day, and he mentioned Bloom's taxonomy, and the goal of an educator using Bloom's taxonomy is to encourage what we call higher order thought in their students by building up from lower level cognitive skills. And you'll see Bloom's taxonomy, and everybody else and the previous speakers have gone through these: remembering, understanding, applying, analyzing, evaluating, and creating. And you'll see there's a whole lot of other characteristics that goes with each particular thought process in terms of Bloom's taxonomy. So what does it mean for us? It means that, look, we as educators, how are we empowering students to basically have these cognitive skills, and how can we transform that into higher order thought? And I come from a university background, and we find that when you are empowered with the fundamental skills at these lower levels, that's what leads up to the more complicated higher order thoughts, and it's able to transform you into a good researcher, a good scientist, whichever you want to go towards. So in my next slide, I'm not going to go through everything because this has been said. So I'm just going to alert you to the main headings. Why are we doing an assessment? So before you set an MCQ question, you're asking yourself the question, is there a genuine interest in the ongoing process of identifying the strengths and weaknesses reflected through student performance? You need to create a plan of your assessment. The best way to determine the reason for doing your assessment is by examining the focus of the plan. So is the focus simply on collecting data? So you've got to really sit down, and I want to sort of home in on you as a teacher, you as a person, you as an educator, giving knowledge to the other person. So before you sit down and think about your assessment, and you're going to ask yourself, why am I doing it? Why? And if you read at the top, there's a nice one, and we at the university, the purpose of an assessment is simply to satisfy the administration, your line managers. Perhaps you want your Department of Education to give you a performance bonus. I don't think many of us want to do that, you know. We obviously have a genuine interest in our teaching and what we want to do. So student learning principles, don't worry about the slide. It's a very, very busy slide. As I said, I'm not going to go through each one of them, but in your time, when you read my slide, it gives you the student learning principles. Has your institution, or have you given a clear idea about the learning outcomes? When you go to your school and when you teach, what is that learning outcome of that? Basically, this particular slide talks about that, using learning goals as well as knowledge about learning as drivers for organizing instruction, provides an environment with signal support for student learning at all levels. In South Africa, we have a big problem because we have 3 different types of schools, and our the so-called government schools, we basically have huge problems in terms of providing support. And so the school or institution promotes an atmosphere of critical reflection about teaching and learning. I'm going to give you some feedback from a South African perspective, and I'm sure many of you also have the same in your schools. in many of our schools, we have huge problems in providing that atmosphere of critical reflection, because the teachers are not very much in line with the giving that support, etc. I know you guys are here, teachers that are listening to my talk are really passionate about it, and I'm sure you have this drive towards imparting students about learning principles, and I'm sure we all do that all the time. Now, fair assessment practices, and you'll find that I've also put in these people that I actually went for a course about 5 years ago at our university, and they required lecturers and academics to go for this university. I can't even remember the name. It was called University Induction Education Program that was run by the School of Pedagogics. And we have, if you saw in my earlier slide, we had this Edgewood campus, and they train our teachers, and some of them asked us to do this particular course. And I actually took some of these slides out of that because I felt it was important to understand what are fair assessment practices. And you can go through these points. Have you clearly stated the learning outcome? Share them with your students. You can't simply go and teach something and then assess something else. Match your assessment to what you teach. Use many different measures and many different kinds of measures. Help students learn how to do the assessments. I know I've set some MCQs, and initially I said I'll talk about 2x2 matrix and 3x3 matrix, and Dr. Brijesh in his talk said that we mustn't actually use that. He was quite correct. I used that because I felt that the engineering students would, how could I set a higher level of understanding, and help students learn how to do the assessment task. Engage and encourage your students. Interpret assessment results appropriately. Evaluate the outcomes of your assessment. At the university, when we do our MCQ questions, we basically have a very nice, we have a machine assessed MCQ sheet, which is marked, and we get what we call discriminatory index or discriminatory indices. We can actually see which question was answered by so many students in a class. I take those statistics and I use it. So if it was a task on stoichiometry, or if it was a task on a calculation based, I can match the two and say there was a large amount of students that didn't like the calculation based questions and they got it wrong. Assessment by multiple choice questions, and Stephen et al. There was a group, and the advantages of applying MCQ questions. Most of us know that obviously it's minimal time required to reach each question. Avoiding trick questions, use of the active voice, need for having the questions peer reviewed, avoiding giving unintended cues, that is such as making the correct answer longer. You've heard all of these and you know about these. You'll also find that most of the presenters, we talk with the same voice, we tell you the same things. So I'm not going to actually go much over these. You can read some of the references that I've got here. It actually gives you quite a nice background about those things. And here I talk about strengths and weaknesses of multiple choice questions. So you can see the strengths and you can see the weaknesses. Go through them and see what are the strengths and weaknesses and how you can use this information. As I said, I'm not going to go through all of them because you will have access to my PowerPoint slide. I want to get to the crux of my talk this afternoon. So here's my starting basis of my talk. And I want to engage with you, the teacher. And I want to say, let's start at the beginning and visit a typical school system based on a school prescribed curriculum for that country and align to the school learning principles. In other words, you would have told your students, look, this is what you are expected to, this is what I expect of you. This is how you should be learning. And these are the assessments that we'll do, etc., etc. Here's a typical scenario of a school in South Africa. Step one, the teacher walks into a classroom at the start of his lesson. Step two, the lesson starts and the topic of the lesson. So we talk, the teacher is talking about assets and bases. And step three, at the end of the lesson, the teacher walks out. My question is, are you, the teacher, confident leaving that class? that you achieved your aim for that particular lesson? And how did you engage?
Yeah.
So in that lesson, let us pose the following questions. And I want you, the teacher, to ask yourself that question when you leave that lesson. Was the mode of delivery correct? Here you can see somebody delivering a package. Now, in South Africa, you know, and I'm sure in India as well, we have a lot of delivery people. And now in COVID times, we have these modes of delivery. Imagine you getting a pizza, you ordered a burger, and somebody is delivering a burger in just on his hand. When you get a pizza, you get it in a nice box, a very nice covered box. The mode of delivery is important. And then you see the picture, I've got teach, and the reflection is learn. So basically what we teach, is it a reflection of what students have learned, and vice versa? Or what the students have learned is basically a reflection of what we teach? We've got to ask ourselves these particular questions. So what was the mode of delivery? Did you write on the board and students asked to write down the information? Did you give them printed hand notes? Did you give them the appropriate diagrams, pictures, flowcharts, illustrations? Did you ask them to go online and you posted notes like some of us have on our learning platforms now with COVID-19? Did you upload it on somebody's PC and said, look, you can download it on your PC, you can use your smartphone. Many of us are learning through our Android devices. The world is gone digital. Is it appropriate? So then what was the level or the pitch of your delivery? And you know, when we learn musical notes, I must share a nice story with you that my good friend that lectures with me, he's from Punjab, Amritsar. He's just got promoted to professor, associate professor, Professor Parvesh Singh. And I always tell him I want to go and visit Punjab. And I think there's some teachers here that are from Punjab, and I want to go to the Golden Temple. And so we have a radio station called Hindwani. And in South Africa, the artists are trying to sing, but their pitch is not right. And his wife, Neha, will say, you know, Ajay, you South Africans can't sing. So I said, Neha, look, the pitch is not right. Things are not right. So basically, your pitch is important. Just the basics as the prescribed curriculum. What was your pitch? Did you just, you know, speak about the basics? Did the teacher step up a notch and talk about much more fundamental concepts with acids and bases? So for example, did you go into organic acids and bases? Did you talk about the pH, which is the minus log of the hydronium ion concentration? Did you mention about pOH? So for example, when I walk into my first year class and I ask students, what does P in the symbol pH mean? And not many students know what the value of P means. And then I ask them, can the pH be a negative value? And they all sit very, very puzzled. So the information, the pitch, and how you share that information is important. You know, we talk about conjugate acid-base pairs, dissociation constant. Are we taking that to a level, and is it important to take it to that level? And I'll talk about the Olympiads, and I'll show you how we can link, you know, taking it a notch higher, and how we can engage the critical thinkers and the smart thinkers in your class. I'm trying to get it to the next slide. There we go. So what types of questions and calculations have been posed during that lesson? So I'm still talking about your lesson. I'm sorry about the color here. I'll try and change that later. What types of questions and calculations were posed during your lesson? Were they only theory questions? Were calculations straightforward, as in simply applying formulas, molarities, mass over molar mass times the inverse volume? Did you give a mixture of theory and calculation-based questions? Were the given examples of theory and calculations at the basic entry levels? Did the teacher cater for higher level thinkers? And how did you do that? So I'm trying to inculcate this way that you, the teacher, is going to basically now set up your question in terms of your lesson. You've got to link the two. And this is the bridge that I'm talking about as well. I'm not too sure if I'm controlling my slide or if somebody else is controlling my slide.
Sir, it's with
Hello.
you.
You are doing it.
Okay, then I'm stuck at the moment. Just bear with me. I'm sorry.
Sean, you can help him.
No, sir. Unfortunately, it's his machine, so I cannot get into his machine.
So, but I have sent you his presentation.
Okay, hang on. It's fine. It's
Okay,
going through.
it is-
I'll just click
it is
on the
working,
slide.
it is
itself.
working,
Yeah,
it
it's
is
working.
working.
Thank you. Sorry. So, did the fundamentals of that lesson reach out to all students of different intellectual capabilities? Pictures tell 1,000 words. Look at this picture on perception. What the student sitting behind the desk and what he's perceiving to what you're saying, the teacher is saying number 9. The student is looking at it number 6. So you've got to have a very clear perception of what you're saying and what you're talking about. And then let's look at the picture on the people, on the students at on different levels of critical thinking, and that is important in terms of what we're trying to do. So the next step is the teacher's assessment. Reason for the teacher's assessment, and it has to be done. Does your assessment need to be done according to your performance management? Look, I want a 100% pass rate. Then you know what, my principal will nominate me for promotion. To get an understanding of the fundamentals taught, you as the teacher, do you really want to see? And I think number 2 basically epitomizes us as teachers, educators. We want to see and get an idea of the fundamentals taught, get an understanding of whether learners are engaging with the content. And that comes from your questions and what we say. The types of assessments, now multiple choice. I'm not going to go through because everybody else has given you the reasons for multiple choice and why we do multiple choice. So I'll quickly go through that. I want to talk a little bit about descriptive questions and stepwise based calculations. You know that you do that. And the reasons for why we do that is that we feel that students will engage closely with the content, learners will understand and remember the fundamentals, and the answers will give you feedback on the capacity of thinkers. So I'm going to go quickly because my talk is obviously on multiple choice questions. You may have a mix of multiple choice questions, and you have a mix of descriptive and calculations. And the reasons for these choices, again, you can, it's based on your institution, it's based on your head of schools, it's based on what you do. I want you to, I'm going to go through this here and say, irrespective of the type of assessment, the primary objective entrenched within the mind of the examiner is projected by the type of question posed. What I'm saying here is that what you've taught is what you want to put in your questions, because you can't separate the two. And the response and the outcome of the assessment is a reflection of the learner's understanding of the content taught. So you are the forefront, you are the face of the class. You've taught that information. And now, basically, you're going to look at the response. Sorry about the spelling here, response, I should have done that. Now, you know, I don't know if many of you, I did Shakespeare in school and I did Macbeth. And in Shakespeare's Macbeth, King Duncan said to Macbeth, there's no art to find the mind's construction in the face. And what had happened was, Macbeth was a very, very ambitious soldier, and he wanted to become the future king. So his wife, Lady Macbeth, kept on telling him that you'll become the king, and they plotted to kill King Duncan. So that's why King Duncan said to Macbeth, there's no art to find the mind's construction in the face, because Macbeth was truthful and he was portraying a very good mind to King Duncan. But his wife kept on corrupting his mind and kept on leading him down the wrong pathway. So it is very important for us to understand, you know, that kind of concept. And then I ask a very nice question here. Is MCQ the art to find the student's mind's construction in the marks? Now, please, when you're quoting this, quote my name, because I came up with this very nice quote and I'll become famous one day like Macbeth. So let's move on to our next slide. And typical school curriculum-based questions based on multiple choice questions. Now, I'm looking at school curriculum-based questions, and maybe in other parts of the world, it's slightly different. Quantify and prioritize the sections taught. This is how I do it, because if I look at, for example, the sections on matter and measurement, significant figures, mass relationship and stoichiometry, volumetric analysis, I sort of look at these 1.3 and 1.4 as a high priority. And in my test, I will tend to give much more significance to those. So going forward, your mass relationships and stoichiometry, volumetric, may be regarded as the high priority. Macro and measurement and significant figures are important, but they will help to understand, and it's more the mass relationships and stoichiometry and the volumetric analysis that tends to take us to a higher level. So here is a simple and direct multiple choice with a single answer option. I'm going to just tell you, you've been through many of this. I think the previous speaker gave a fantastic idea. Dr. Brijes's talk was really nice because he told you how to do about types of MCQs, and we're all talking in the same language. And here you can see a simple and direct type MCQ with single answer options. This is typically what we set, and this is typically in red of my slide. I've basically, I've actually seen some textbook give 5 options. If you feel that the answers, it's a simple MCQ, you may opt to give 5 options. I didn't hear about the other speakers talk about negative marking. And I don't think many institutions give negative marking, but you may want to implement negative marking. For example, if the student gives an incorrect answer, that you're going to basically minus half a mark or minus a quarter mark. Negative marking, I will remind you that in the Olympiads, negative marking is implemented in the Olympiads. So we do implement negative marking. Simple and direct type of MCQ with variable matrix. I'll talk a little bit about this. I know many of the others did say that it is not the way to set, and I agree with them. However, you may find that if you want to engage the smart thinkers, then you may go with these types of what I refer to as a 2x2 matrix, because you basically have the different options, which gives you in terms definite compressible, definite incompressible, and you can see it also gives you a smart option to basically give your options. Now, smart thinkers will use a process of elimination if they understand that a solid has a definite shape. So if they look at solids have a definite shape, then they'll simply remove indefinite, and they know they've got to work with A and B. So you also have to understand, this comes with a good understanding of the fundamentals of what you've learned. Simple and direct type calculation-based MCQs with single answers, you've seen this as well. You can see mine is a bit disjointed. I've actually taken this directly from a textbook, and the textbook is actually given the random options, but now we have been asked to basically order them in either ascending or descending. Now, textbooks, for example, will give, or test banks will not tend to give you the options in ascending or descending. So just be careful of that. So here's a very simple type of question that's calculation based. I just want to draw your attention to the formula. We can make density the subject of the formula. Then you can change the question to make mass the subject of the formula, and then change the question to make volume the subject of the formula. So you can get 3 questions basically changing the subject of the formula. I move on to my next slide, is what we refer to as complex calculation-based MCQ with a single answer options. So here you look at a typical question: how many moles of sulfuric acid are needed to react with 14.64 grams of sodium hydroxide by the following reaction? And here is a balanced equation, and I've actually shown the answer, how you would basically give it as a typical written type of calculation. So I've actually put in mark allocations. If you feel that you want to increase the marks or decrease the marks, you can do so depending on your assessment and the content and how you engaged with your particular students. So let's bear in mind now the stoichiometry of the equation. The calculation I gave half a mark, and here is an important aspect for me where I've given a mark for the actual values put in. So I'm saying a possible mark allocation could be 3 to 4 marks. Now, I want to convert this into a multiple choice question. And here you can see how many moles of a sulfuric acid are needed to react with 14, so it's the same question, and I've given the options, right? I've given the options, and here again, how did we arrive at the incorrect answers? Students will mimic these answers during the calculations, meaning the distractors, and the wrong answers will point you to where the students are going wrong in their calculations. So the correct answer is B, but I want to draw your attention to the distractors and how you can, when you're preparing your MCQ questions, I would ask you to basically do it in this particular fashion so you can then get an idea in terms of the calculations and where students were going wrong in the calculations. So for the incorrect answer in A, I basically looked at the stoichiometry of the stoichiometry is ignored, meaning you simply look at a 1:1 reacting ratio. For the answer in C, I swapped the stoichiometry in terms of the getting the wrong answer. And for the answer in D, I basically divided the mass by the molar mass of sulfuric acid and not by the sodium hydroxide, etc., in my calculation. And you can go through this. So you can see how to set up your calculation-based MCQs so you can give feedback in terms of your calculations. And you can see exactly where they went wrong. This also can, you can set up a test bank of questions, and you can simply change the mass of your initial amounts, and you can carry on with a test bank of questions that you have. Now, my next video is to, my next slide is, let's step up this problem to a higher level question. How many moles of sulfuric acid are needed to react with 14.64 grams of sodium hydroxide by the following reaction? And here, notice in the previous question, I've given the atomic weights. In this question, I say periodic table is provided where I expect the student to basically calculate the molar masses. Now, we are basically imploring the student to calculate the molar masses and use the periodic table. Data constants are important aspects of science, and students are expected to engage with data constants, with the periodic table, and understand how to use them. So this is one of the reasons, or to try and engage students to work with data constants. And then notice the equation here is an unbalanced equation. So the difficulty is elevated because students need to balance the equation for the reaction. But now let's see the downside to this. And you know, for a class, and depending on your class, we're saying that if the student does not balance the equation, then the student cannot proceed to do the calculation. So what are we trying to basically question here? So this may seem to be unfair, an unfair situation in your multiple choice. I'm alerting you to these particular facts when you set multiple choice questions, that it is what we call double jeopardy, meaning that if the student is not able to balance the equation, the student cannot move forward. If the student gets the balancing right, then he's faced with the next problem of getting the calculation right. But it is a high level question, and a smart student who's engaged with it, who's basically been able to answer this, is one of those students that you know he's engaged with the periodic table, he's balanced the equation, and he's answered that particular calculation. So you've got three aspects of a smart student that you're basically engaging with. So here is an example, in my opinion, where you can set it at a level for your smarter thinkers, and a type of question in that particular. Right, so here's an example of what we refer to as looking at simple trends. And simple trends, where we're using MCQs with simple trends, you give the compound, you give the boiling point, for example. So from the following data, the order from most polar to least polar for the following compounds. Now here, all we're doing is a smart learner will know that it basically has to be increasing or decreasing, and you can simply look at a trend, okay? So are we testing, we're not testing the student's ability to engage with, for example, intermolecular forces to understand. We're just asking them to look at trends. So a student will know that in this case, we're basically going to engage with a trend. And if you look at the data, I can simply just order it in highest to lowest, or lowest to highest, and simply work with that data. So that's what I'm trying to show you here in this particular, I would say, avoid simple trends, because you're not engaging the person to understand much about the content of what you've taught. Okay. MC questions that require fundamental understanding of rules. And here in this particular question, you engaging the student to understand solubility rules. And here you're asking the student to look at each particular equation. Now this is a bit, the D, I call it a bit of a sneaky, because we bring in the idea of amphoteric hydroxides, and a student, and a smart student can come up and say, but sir, aluminium will basically precipitate some aluminium hydroxide, and then it will obviously form an aluminium hydroxy complex. Now you can know that he's a smart student, but when we got to ensure that your question says complete mixing, you know, your question needs to be also very, very clear in terms of, so this type of question requires fundamental understanding of rules. And here I'm trying to explain solubility rules and how you can set questions with particular rules that we engage with. I don't have much to go, and I hope I'm within the time, but Olympiad quizzes and how they are different to school-based quizzes. I must tell you this, that whenever I go to the International Junior Science Olympiad, and whenever I go to the International Chemistry Olympiads, which are the senior Olympiads, we call it ICHO, I look for my friends from India, from the Homi Bhabha Center, Ankush, Dr. Brijesh, there's Ankush and all my friends. And I like to talk to them about how things are going there, because when you go to the International Junior Science Olympiad, and if you go to the International Science Olympiad, this year in 2019, December, it was held in Doha, and the Indian team got 6 gold medals. And I said, my word, this is really, really fantastic. So when I go to the International Junior Science Olympiad, and if the other countries ask me which country I come from, I said I'm from India, so that I could boast about the 6 Olympiad gold medals that we have. So what are they doing, and what right are they doing? So we have national Olympiad quizzes, and these are pitched at higher levels than the school's curriculum. And the intelligent, hardworking, and dedicated learners do well. So, and I'm sure, you know, you see this with your kids. Obviously, all kids are bright, but some are brighter than the other, and hardworking, and much more dedicated. And then you obviously will have those that get higher, you know, that will do better than the others. In most countries, all learners are allowed to participate in the national quizzes. Generally, the brighter and engaging students are identified by the teachers. So, you know, in South Africa, the teachers generally ask the brighter ones and the harder working ones to participate in our quizzes. International Olympiad quizzes are extremely high levels, and participants are generally high academic achievers. And these are born out of the national competitions and further selection tests. I know in China and in India, the initial selection starts over 200,000 students that sit for these selection tests. In South Africa, we have 2,000 that we start off at the initial national Olympiads. So you have an idea as to how difficult these Olympiads are. Olympiad-based questions are generally a combination of several topics within a question, which are complicated and may require advanced theoretical knowledge and complex equations and very good mathematical skills to arrive at the solutions. I'm going to give you an example in my next slide. So here, basically, understanding content and linking it to questions. I put the slide in this morning. So if you have simple descriptive content and we ask a question, for example, what is the melting point of sodium chloride in an MCQ question? Or what is the boiling point of the organic solvent carbon tetrachloride? But if we want to now ask students to engage with in-depth content or with complex content, we then can change that question around. And we can say, explain why sodium chloride has a high melting point at approximately 804 degrees. And then we can rephrase question 2 as explain why carbon tetrachloride exists as a liquid at room temperature. Now you can see the two ways in which we phrase the question requires different content that needs to be taught to the students. And why I said that is because this is how, for example, I'm giving an example of a grade 11 physical sciences Olympiad quiz that was organized by the National Science Olympiad in our country. A label on a reagent bottle contains the following information: 38% HCl by mass. We're given the density, the molarity of the HCl is, and we just give this type of information, and we expect the student to engage with his knowledge, the complex content, and to do the calculations and basically come up with an answer. So you can see the type of Olympiad questions that are set. Let me go on to the next slide. And here is the example of the, I've actually taken this out from the International Junior Science Olympiad that was hosted in Doha last year. And you can see the type of question that they're setting. Generally, they give a preamble. All kind of life on Earth requires water, which cycles through our ecosystem in 3 states: solid, liquid, gas. The relationship that these 3 phases have with both temperatures and pressure in a sealed container are best represented in the phase diagram below. So this is the preamble to the question. And here comes the question. So consider the following statements and identify the correct ones. And here you can see, now remember, I know previous speakers said that, look, you don't go with the 2x2 matrix type of questions, but as I mentioned earlier, the Olympiads do engage with 2x2 matrix type of questions. And you can see it basically will engage students at a higher level. So I don't think it's a bad idea. Dr. Brijesh, I know you did say in your talk that it is not the way to go as far as, but I think it provided that the MCQs are presented in an amicable way, in an engaging way. It implores the student to engage with content. I'm sure then you can set a question of this nature. Okay, so here's an example of a 2x2 matrix and what has been set at the Olympiads. One more question is water sustainability, and this was a multiple choice set in December 5th, 2017 in Nijmegen. This was at the International Junior Science Olympiad. Now, my gosh, let's look at this particular question: determination of oxygen.
So please, this is the last question, sir. Then
yeah, this is my last. Thank you. So dissolved oxygen, and you can read the content. This is obviously an indirect iodometric titration that we teach at 2nd year analytical chemistry. And you can see the preamble to this question. There's a lot of data. These are at higher level Olympiad types of questions. And which of the following errors could be responsible for the result? And here is the type of MCQ engagement. And here's the question based on this particular MCQ question. Have a look at it, and you will see that basically how these types of questions are engaged at, and I've put in the solution so you can see how the examiners have engaged with the solutions to these particular problems. In my closing remarks, according to Bode and Associates, assessment is designed to focus students on learning.
Voice is not audible.
And can you hear me now? Assessment is designed to focus students on learning. Assessment practices response to diverse expectations and experiences of students. Assessment design is recognized as an integral part of curriculum planning from the earlier stages of the course development. And teachers are the foundations of academia. They impart the first academic impression upon us. So, you know, the great Nelson Mandela says, we can change the world and make it a better place. It is in your hands to make a difference. And teachers are those people that do that. So thank you all, teachers. Dhanyavad. Teachers make a real big change to us in the world. And I would like to thank you. And I would like to thank the teachers for taking the time to come and listen to this. And I wish you all the very best. Thank you very much.
thank you, sir. Thank you for your encouraging words and a wonderful presentation. I know that all our participants would benefit hugely from this. And now I'd like to move ahead with our third speaker.